In this video, we are going to see about the power factors of the synchronous motors. In an induction motor, so you know that only one winding is there, that is a stator winding, that produces a necessary flux. That means the required flux, it will be supplied by the only one winding that is placed in the stator winding, right? The stator winding will draw the reactive power from the supply, that means the source, AC source, to set up a flux. Okay, and also you have to know that the induction motors are operating at the lagging power factor. Okay, but in case of synchronous motor, you can notice that there are two possible source of excitation. One is the alternator current in the stator, that is the three-phase supply given to the stator, that will establish a flux. And another thing is like the direct current in the rotor. So that is the direct current will be supplied to the rotor to set up a flux. So you know that there are two fluxes. Okay, the required flux may be produced either by the stator in case that means a lagging, or rotor, or maybe from the both. Okay, so if the rotor current is supplied the required magnitude, okay, so the required magnitude of flux, so then there is no magnetizing current or reactive power is needed in the stator. Okay, so the result will be the motor will operate at the unity power factor. But in case of the rotor exciting current is less, so previous case is the same, but in this case less, that means the motor is under excited. So the deficiency in the flux can be made up by the stator. So it is not supplying the required flux, so the some portion of the flux will be compensated by the stator. Okay, now the motor draws a reactive power to provide the remaining flux. So in this case the motor will operate at the lagging power factor. Okay, next one, in case of the rotor exciting current is greater now. Okay, the motor operates at the leading power factor. That means the motor is over excited. The excess flux must be counterbalanced in the stator itself. Okay, now the stator, so usually the stator used to get the or absorb the reactive power from the supply, but now the stator delivers the reactive power to the three-phase lines. That means it delivers the leading power factor, leading reactive power. Okay, now the motor behaves like a source of reactive power, that is a leading in nature, so it's like a capacitor. Okay, now the motor operates at the leading power factor. To conclude, the synchronous motor absorbs the reactive power when it is under excited, delivers the reactive power to the source when it is over excited. Okay, so with that we can see an example. So this is one of the application of the synchronous conductor. So